how to solve an equation, okay, or to start solving an equation. So this first one is talking about equivalent equations. Basically what that means is two equations can be the same as long as you're doing the same thing to both equations. Okay, so they can be reduced, they can be simplified, and so they give you answers is what we're really looking for. So when we're looking for equivalent equations, our goal right now is to get an equivalent equation that has the variable equal to a number. That's basically the whole thing, okay? We are really talking about solving equations. But what I want to do is if I have x plus 7 equals 19, that's an equation. But an equivalent equation is if I do the same thing on both sides. So if I kind of just look at the equation as two different sides, you have this part on one side, x plus 7. The other side I have 19. So if I do the same thing on both sides, the equation is still equivalent. So let's look and see what that means. Here I want to get x by itself. That's our whole goal. We want an equation that has a variable equal to the number. So I want to get rid of 7. So to get rid of 7, if I have 7 things, I would have to subtract 7 things. But if I do that on one side of the equation to keep them equivalent, I have to do it on the other side. So for a lot of people when they're first starting, I have them draw the line down showing the two different sides of the equation, okay? It helps because you're trying to do the same thing on both sides. You know you have to do it on both sides of that line. So if you put it down where the equals is, it makes it nice and easy. But we've done the same thing. We've subtracted the 7 here. We've subtracted it also here. That gives me x equals 12, which now this is an equivalent equation. It was found by doing the same thing to both sides. Okay, that's what we're doing. You always have to do the same thing to both sides of the equation. Okay. Another example would be if I had 3x equals 39. Okay. That's an equation. Okay. We want to find its equivalent equation by doing the same thing to both sides. Okay, the equivalent equation, I have a 3 times x, and we do the opposite of multiplying to get rid of the 3, because look what we do. If I divide 3 by 3, I will get 1x. 3 divided by 3 is 1. 1 times x is the same as x. So what I end up here with is 1x. I also have to do the same thing on the other side, divide it by 3. So 39 divided by 3 is, anybody know? 39, 13. So 1x is the same as x equals 13. So I have now found out what the answer is, but these are equivalent equations because as long as you do the same thing on both sides, they stay equivalent. Okay. So the idea of keeping the equations equivalent is the whole idea of solving. We want to get to an equivalent equation, but we have to do the same thing on both sides of the equal sign to get that to stay equivalent. Okay, that's really what section 3.3 is all about. It's just talking about how do I keep equivalent expressions or equations. Okay, so let's go to 3.4. So 3.4 is about solving ax plus b equals c. Basically, we're not solving it with those things. Here, a, b, and c are numbers. X is the only variable. So what we're talking about is we're setting it as a generalization. We're talking about you can put any number in for A, any number in for B, any number in for C, and this will, we're talking about that, how to solve those types of equations. Okay? Now, my thing with solving equations is if you take PEMDAS, okay, when you do the solving of equations, we are going to go backwards of PEMDAS. So we are going to use the SAD MEP, way. So this is order of operations. To solve, we go backwards. Or you could think of it as in the opposite order. Okay, so that's always key to remember. So what would we do first? We're actually going to do last in order, from order of operations, whatever we did first, we are going to do last. Whatever we did last in order of operations, we're going to do first. Okay, so that's some things to think about as you're doing this. We are also going to use opposite operations. Whoops, that's not how you spell that. Okay, so let's give an example. I have 3x minus 5 equals 72. I made this up, so it will probably never come out even. That means we'll probably end up with a fraction, but that's okay. Okay, notice it's in this form. There's a number in front of x. There's a number, remember subtraction is very much like adding. Okay, there's a number subtracted or added to that. There's the equal sign, and then there's a number c, which is on the other side. Okay, so what we're going to do is try to solve that. Solving it means we're finding what does x equal. That's where we're trying to get down to an equivalent equation. Okay, now we're going to show a step by step instead of guessing. Okay.
No, I didn't guess it.
Oh, okay.
I did it on my thing already.
Okay, well, just wait, okay? So when we're doing that, we want to make sure that we are getting down to an equivalent expression of x equals. Well, what x equals is the only number that I can put in there to make this equation true. So we're getting down to x equal, that's our goal. But this value that we get, the x value, is the only number that makes the statement true. Because there are not several answers I can't take several different numbers and multiply them by 3 and subtract 5 and get 72. There's only one number that I can multiply by 3, subtract 5 and get 72. There's not a whole bunch of them, there's only one. So the one we're trying to find is the one that makes it true. Okay? So we do it by using equivalent equations. We do the same thing on both sides. And then we also do it in the opposite order of PEMDAS, and we use opposite operations. Okay, so let's look at this. We have 3x minus 5 equals 72. So normally we multiply first, and then we subtract. But we're doing the opposite of that.
So you'd subtract 5 from 72.
We're actually not going to subtract. You know what we're going to do? What we're going to do is we're going to add 5 because I want to get rid of 5 on this side. I want to make it go bye-bye. So if I add 5 here, and I will also add 5 here because I have to do it on both sides of the equation. But what I have is negative 5 and positive 5, which is 0. So 3x plus 0 is really 3x. I don't require you to write this line. I just want you to know that what I got here is 0. So 3x plus 0 is the same as 3x. Okay? This line you do not have to show. Okay, I just put it there so you know it. Then I do this work, 72 plus 5 is 77. So the first thing was to get rid of whatever was added or subtracted by doing the opposite operation. Notice this is subtracting 5, this is adding 5. So I subtracted 5. I got rid of the negative 5 by adding 5 because a negative 5 and a positive 5 make 0. So since I added 5 here, I have to also add 5 here. I will keep them the same.
So now we divide
Yes.
3 to 77.
And why we divide is because I want to get rid of this 3. The only way I can really get rid of the 3 is make it a 1 because I don't want to make it 0. I do not want to make it 0 because then it would be 0 times x. That doesn't make any sense. We really want it to be 1 times x. So our goal is to get 1 times x, which 3 divided by 3 is 1. So I have 1 times x, which we know is the same as x. So our goal here was to get 0 because we were adding and subtracting. Our goal here is to get 1 because we're multiplying and dividing, okay? That means I also, though I divided this by 3, I must keep them equivalent by dividing that by 3, okay? And if I divide it by 3, it is not going to go in. 3 does not go in even to 77.
So it's a fraction?
It's a fraction, and I can actually leave it as 77 thirds because I can't simplify that, and I can leave it as an improper fraction. Do you know why the improper fraction is preferred? What would?
Does it look nicer?
Well, and it's also usually exact. What? Now, because this is 3, it would keep going. Well, what did you get in your calculator?
25.667.
Well, and it goes on for
6.
We can't write the exact number because 6 goes on forever. So actually, this is more exact. A fraction is more exact than a decimal. So we prefer it in exact form. So 20, did you say it was 23?
25.666.
0.6 repeating. So this is more exact. This is actually not an exact number. Okay, it has to be rounded. That's why we go up to 6, 7. Okay, but just knowing that, keeping it as an improper fraction, you don't have to change it into a mixed number. You do not have to change it into a mixed number at this point. Okay, that makes sense? Okay, so let's try a couple more. And you're gonna think about the opposites. I want you to practice this. I may write the problems a little differently though, so you have to think about that. Okay, so at your desk right now, on your note paper, I want you to take this. Okay.
You want us to solve it right
I
now?
want you to solve it. Okay, think about what you're gonna get rid of first and how you're gonna do that. If you're stuck, I'll come around and watch what you're doing. Okay,
Okay. Done. Fine.
not really a score. How did you get rid of it? You can't subtract it. What is it? Yes, how do I get rid of it? What did you do first, okay? Well, you're gonna subtract 4, that's correct. Yes. Perfect. Oh, okay, oh. I like the light bulb coming on. I'm getting tired of that.
I thought that the 4 was negative, but it's not negative.
No, it's not.
So that is that, and that is that.
What did you lose there, Mason? What is this thing in front of 7?
Minus.
Or it makes it a negative. Okay, now what am I gonna do to solve? I want 1x, because I want to give him 1. So if I subtract 7, or am I dividing it 7? I'd have to divide, I do the opposite, it's multiplication between this. The opposite is divide. So -7 divided by -7 is 1, so about 1x equals, and I have to do the same thing on the other side. No, what did I do on this side? What did I do right there? I'm gonna divide this by 7. Let me see, can you do it?
Wait,
Oh,
divide
just
20 by
leave it
7
as
or
that.
20 by negative 7?
Okay.
20 divided by -7.
I don't remember how to do that.
You're gonna get an improper fraction, because 7 doesn't go into 20 evenly. So we're gonna leave it as x equals
20 over.
20 over -7, negative 20 over 7, or negative 20 over 7. 3 ways you can write that answer. Okay. So I'm gonna go quickly through this. I think some of you, I don't want you to get it in the decimal form. Right now, I want you to leave it as exact form. Okay. So in this case, I want to get rid of the 4 first. This is the 4. I have to look at what its sign is. Its sign is positive right now because the sign is given in front of it, not behind it. It's always given in front of it. Okay? So this is a positive 4. To get that to 0, our first goal is to make that 0. Get rid of 4, so it's 0. So I'm going to subtract 4 here, and I'm going to subtract 4 here. Because 4 minus 4 is 0. I made that into a 0. And what I have left is -6 or -7x. Do not lose that -7. Do not lose the minus sign when you're doing this. Okay, it goes along with it. Okay, equals 20. Okay. Now, my next goal is to get the number in front of x as a 1. Right now, the way you can tell what to do is this is the multiplication sign. To undo it, we do the division. Okay? Because what is negative 7 divided by negative 7? It is 1x. That gives us what our goal is, 1x, because 1x is the same as x, okay? Over here, I have to do the same thing. I have to divide by negative 7. So see how I subtracted 4 on both sides? I did it in different, so you could see it. I divided by negative 7 on both sides. First, I got rid of this to make it 0. Then I divided to get this to 1. Okay. This can be written several different ways, okay, as an exact number. When we have a negative, you can leave it as 20 over negative 7. That's the same as negative out in front, 20 over 7, which is the same as negative 20 over 7. All three of those are identical. All three of those are the same answer. I will say which one I prefer. I happen to prefer this one. I prefer the negative always to be written in the numerator. The reason I don't prefer this one here is because it gets very, I can't tell if you just like your pencil skipped there or if you actually meant it to be negative, okay? So I like it up in the numerator. So if you have a negative in the denominator, just move it up to the numerator because it's the same answer, okay? Now, will I count these wrong? Absolutely not. They are the same thing. This is how I prefer it. I'm just giving you my pet peeves. I like to look at it that way because my eyes are old. That's why I have to wear these glasses. And I can't see if that's really a negative out in front. Okay, so that's something to think about. Just, just humor the teacher and write it in her preference. That's all you have to do. We'll get along fine then. So, okay, so that's one way of doing these. So I think that's basically the idea. I think right now we need to practice some. We only have 3 of you, so I guess 3 people can, each of you can have your own board.